Welcome to day 4. We are only doing one lesson today because we also have an assessment. This first lesson is describing a graph. There is a lot of information, so please make sure you stop and take notes as needed. Again, you will have to upload a copy of your notes, so please make sure that you stop the video as much as you need to take time to put good notes on a piece of paper. You will need to use those notes as much as you can over the next couple lessons, so make sure that you write down some good notes. Here we go. So today we're going to be doing describing a graph. Whenever you describe a graph, you have to include all of these attributes. So there are 1, 2, 3, 4, 5, 6, 7, 8 things that you must include every single time. Even if the answer is they don't have any of those, you still have to write, line of symmetry, none, or domain and range, none. You have to include all of these attributes. So again, I would make a little list of this whole section, so that way you have it for every single time you see a graph. So now let's talk about what each of these individual things represent. Shapes. Shape is your easiest one. You are basically going to tell me what shape the graph is. The only one that has an actual name currently is a line. It's going to be a linear graph. If you see a straight line, it's going to be linear. You might have a U-shaped graph. The official name is a parabola, but again, you don't have to worry about the official name right now, just what shape is the graph, so I know what I'm looking for. Maybe a sideways S, maybe a V shape. You might have two curves that are opposite of each other. Maybe you just have one curve from the center of the graph. Again, we have a curve here, or we have a circle. These are our different shapes. Again, this is the first thing you're going to tell me about the graph. Very simple, easy. The second thing that we're going to talk about is the line of symmetry. First of all, we have a definition right here. The line of symmetry can be defined as the axis or the imagery line that passes through the center of the shape or the object and divides it into two identical halves. So again, think about if I were to cut this shape directly in half, almost like a piece of paper, could I fold it and it match on top of each other? For instance, this one right here, if I were to draw a line right here and take this piece of paper and fold it in half, both of these sides match up perfectly, which means this line right here that goes straight through the center is the line of symmetry. It already tells you what that line is. That line is x equals 3. So for this graph right here, my line of symmetry is x equals 3. Again, think about this one. If I were to draw a line straight down the center, if I were to draw it right here, this side is not going to match up this whole side. But if I were to draw a line right here straight down the center, which is at 0, going straight through 0, this side, the blue and the red, would match up together. So this line of symmetry would be at x equals 0. This one, I can't draw a line straight up and down and make it cut the figure in half equally. However, I could draw a line right here horizontally and it would cut it in half. So now I'm no longer looking at my x's, I'm now looking at my y's. And right here, it would cut it in half and it would be at y equals -4. So right here, my graph, my line of symmetry would have a line at y equals -4. Okay, over here, if I were to draw a line straight down here and flip this over, this would be on the bottom, this would be on the top. If I were to draw a line right here and flip this over, this would again be right here, and this would again be right here. So there's no way that I can just cut this in half and it fit perfectly with the other one. So in this graph, there is no line of symmetry, which means my answer would be none here. In this graph, again, think about if I were to draw a line going straight down, wouldn't work. If I were to draw a line Going horizontal, it wouldn't work. If I were to draw a line diagonally and then I flip it, would that work? Yes. So in this case, my line of symmetry would be this diagonal line. We don't know how to write that yet, so right now I'm just going to have you write line of symmetry would be diagonal. This is my line of symmetry. Our next one is going to be increasing or decreasing. So we want to figure out, is the whole graph increasing or is the whole graph decreasing? Or are there certain parts that are increasing or decreasing? Because there could be the whole thing's going up or down, or there could be certain spots that are going up and certain spots that are going down. And if we're talking about a straight line, it's always going to be only increasing or only decreasing. So notice this straight line is going up, which means it's going to be increasing. From this negative numbers over here to the positive numbers on this side, that graph is going up. We always want to read this graph from left to right, just like a book. So from the left side of the graph, all the way to the right side of the graph, it is going up. So in this case, we could just write increasing. But I want you to get a feel for how to write the notation. So notice I wrote from the negative sides, I wrote negative infinity. You can draw the infinity sign, which looks like a sideways 8. I just can't do that on my computer. But from the negative side over to the positive side, it's going to be increasing. If I look at this graph, so from this side, if I'm going from my negatives, so my negatives start way up here, right? It's going down until this point, and then it turns and starts going up over here. So from left to right, it goes down, it hits a certain point, and then it goes up. So I'm going to say that it's decreasing on this side. So from my negative numbers all the way to 3, it's decreasing. So from negative infinity to 3, it's decreasing. And then from 3 to positive infinity to all my positive numbers, it's going to be increasing. So for this side of the graph, it's decreasing. For this side of the graph, it's increasing. So this is how I would write that. My third graph here, so it's sideways. So if I am reading it from left to right, so from left, I hit this point. From this point, going up it increases, going down it decreases. So I'm going to say from this point, if I were to say 2, because that's my x, right? I don't know if that 2 on this line, if I say it's increasing, that means that from this 2 it's going to be going up. So I'm going to use my y here since we're dealing with a sideways graph. From my y at -4 right here is the turning point. That's when it turns. So from -4 up to a positive, it's going up. And from -4 to negative infinity, it's going down. My last graph here, I notice there's a bunch of level changes. This red part from here to here is going down, but then this red part from here to here is going up. Then this blue part is going down, and then it goes up. So I notice there's 1 decreasing, 2 decreasing. So I need to say both of those. So right here, these are my negative numbers. So negative infinity all the way down to -1 is decreasing. From -1 to 0 is increasing. From 0 to +1 is decreasing. Then +1 to infinity is increasing. So notice I have 4 different intervals here. So some of them I might just have increasing or decreasing if it's a straight line. Some of them I might have 1 for each, and some of them I might have multiple for eaches. It all depends on what the graph is doing. Alright, next one, maximum and minimum. So maximum and minimum is just your highest and your lowest point of your graph. Imagine if you could draw a line at the highest or the lowest point. If it has arrows, that arrows mean that it continues and it never ends. So for instance, in this graph, these arrows are going to keep going up. So that means this is going to keep going up and up and up and up and up. There is no stopping point. However, there is a stopping point right here at the bottom of the graph. It can't go any lower than this point because that's where it curves, which means this one has a minimum value, a smallest value. The minimum is at -4. There are no other numbers less than -4 right here, below -4. If this was an upside down U like this, then that would have a maximum value. The highest point, the max is whatever the highest point would be at. If it's a straight line with arrows on both ends, these arrows are going to continue out both ways. There's never going to be a stopping point, which means there is no minimum or there is no maximum value. I can look here, same thing with this one. This one doesn't have arrows. If it did have arrows, then there would be no minimum or maximum values. If it had points like this last graph, so if there was a point right here and a point right here, I would have both a maximum at 4 and a minimum at -4. If it had arrows, then there would be no minimum and maximum because, again, it's going to keep going this way, which is the highest, and it's going to keep going this way, which is the lowest. I was looking at it as if it had arrows here. Alright, and then my last one, again, I have a maximum. The highest point it goes is 16. So my maximum is at 16. And the lowest point that it goes is right here in between this -8 and -12, which would be -10. So here again, you can have none, or you can have one, or you can have multiple minimums and maximums. Alright, we have x-intercepts and y-intercepts. An intercept is where the graph crosses that axis. So an x-intercept is any time it crosses this x-axis, this horizontal line. So this green line in this picture. So right here, this is that green line. Right here, this is that green line. Here's the green line. Here's the green line. So x is where is it crossing that? So imagine if that green line was right here, this point right here would be where it's crossing it. What number is that? That number is 7. So we're going to say our x-intercept is at 7. I wrote this as a point, 7, 0, because that was, if we were graphing that point, it would be at 7, 0. This x-intercept, notice this one, if this was the green line, there's 2 points where it's hitting it. It's hitting it at 1, and it's hitting it at 5. So my intercepts would be at 1 and 5. Notice if I were to draw this green line right here, that graph is not even hitting that line, which means there would be none. And then last but not least, if I were to draw this green line right here, again it hits it right here at 0 and right here at 3. So I have 0 and 3. The y-intercept, y is this red line, this vertical line going straight up and down. So again, I have my vertical line right here, my vertical line right here, vertical line right, oopsie. Sorry. Nope, let's go back. Here you go. Vertical line right here and vertical line right here. So if I were to draw a line right here that's hitting at -5, again, if I were to write that as a point, it would be 0, -5. This one hits all the way up here, which is going to be at a +5. This one hits right here at +7. And then this one hits right here at 0. Again, you can have a graph that has none, just like we did for the x-intercept. I just do not have an example of that on here.